The first step is to factor all the denominators. So this needs factoring. But these problems you can always use as a source of hints about how to solve the problem. And in fact, x plus 10 times x minus 4 equal this. That's very typical. So think about that. These certainly look like the factors of this, and try it out. X times x is x squared. 10 times negative 4 is negative 40. The middle term comes from the outers, negative 4x plus 10x. 10x minus 4x is 6x. So we can replace this with its factored form. X plus 10 times x minus 4. And now we want to clear the fractions from all these equations, from both sides of the equal sign. We want to multiply times the LCM of all three denominators. And this is the LCM right here, because everything divides into this. So, multiplying both sides by x plus 10 times x minus 4, this whole thing distributes to each term in the equation. Really multiplies times both sides of the equal sign, and then distributes to each term on each side. So now the result of this is here the x plus 10 cancels with the x plus 10, so we're left with 1 times x minus 4, which is x minus 4. Then the plus. X minus 4 divides into this one, canceling it, leaving x plus 10 times 2, or 2 times x plus 10. And on the right side of the equal sign, it cancels out completely, leaving 1. So notice how much simplified that is than the equation above. Now to finish solving this, I need to clear some space here. Here goes. So working my way upwards here, this is x minus 4 plus 2x plus 20 equals 1. Distributing the 2 through the parentheses here, 2x plus 20. Now we can combine like terms. And we've got a negative, well, we've got x plus 2x. That adds up to 3x. 3 x's, and negative 4 taken away from 20 leaves 16. If I subtract 16 from both sides of this equation, I get that 3x equals 1 minus 16 is negative 15. And that then leads, dividing both sides by 3, that gives us x equaling, 3 goes into negative 15 negative 5 times. Negative 5 is then the solution to that equation. And it doesn't make any of the original denominators equal to 0. The original denominators, it doesn't make any denominator equal to 0. And so that means it's a valid solution. Okay, now let's work on number 82. It works very similarly to number 81. And in fact, this is equal to the difference x squared minus 11 squared, which is x plus 11 times x minus 11. So this factors as the product of those two denominators, x minus 11 times x plus 11. And so what we need to do is to cancel out all the denominators by multiplying both sides of the equation by the LCM of all the denominators occurring in the equation. So then this distributes to each term in the equation, multiply times both sides of the equation, and then it distributes to each term on each side of the equation. So here we go. The x minus 11's cancel to begin with, leaving x times x plus 11. Then the plus. Here the x plus 11's cancel, leaving 2 times x minus 11. Then the equal sign. And on the right, everything cancels, leaving the x squared in the numerator there. This simplifies further. If we distribute this through, we get x squared plus 11x. This is x squared plus 11x. And if we distribute the 2 through the parentheses here, it's 2x minus 22. So that's a great simplification. Now, subtracting x squared from both sides, we find that this really is a linear equation. And x squareds leave the equation entirely. And 11x plus 2x add up to 13x. The x squareds have gone away now. This is all equal to 0. And so if I add 22 to both sides, then the 22 goes away from this side and appears on the other side. Finally, dividing both sides by 13, we get the solution, x equals 22/13. And that doesn't make any of the denominators. It would have to be 11 or negative 11 to make a denominator 0 in the original problem. So this checks out. Okay.